So one of the mainstays of older equipment and vehicles and air conditioning systems is the Frigidaire A6 compressor. It's used in a ton of stuff over the years. Cars, equipment, John Deere used them, Freightliner used them, etc. Long list. It's a good compressor. It's very heavy duty. It's very strongly built. It has its own oil reservoir here, and some people even turn them into air compressors because it has its own oil source and pump. It doesn't need to use the oil circulating in the system as a lubrication for the compressor itself. So, mainly. So you can use them as an onboard air compressor. Anyway, they're that durable. So, they're getting kind of expensive to fix and replace, and the alternative these days is the aluminum version of the A6 compressor. I had somebody ask me, is it worth it to stick with the A6 compressor? They cost a little bit more, and I figured I would show some data and some information, and then you can make your own decision about which is better, especially for your purposes, because they are so very, very different. Even though they have the same bolt patterns and they'll bolt up to the same place and everything, and they're an exact replacement supposedly, they are very different inside and in design. So I figured I'd show you some actual data. We'll do a tear down, we'll evaluate what's in these things, and I'll show you basically the complete differences of them, and you can make your own decision based off of that. So let's dig into these things, strip them down, and see what we have. So obviously the clutches are different. This has a newer style, more compact electromagnetic clutch, and this has an older, kind of beefier, more clunky electromagnetic clutch. But the end result is they pretty much work the same, so I'm not even gonna really deal with that. You can see this one has an actual reservoir for the oil. This one, although it has a plug and kind of pretends to have a reservoir, it doesn't, which we'll get to see inside when we open it up. It's kind of pretending. Most compressors don't even have like a separate drain plug for the oil, because you just fill it through the ports in the back. And this one, I don't even know why they put this in, because it doesn't have a separate reservoir. But this one does indeed have a separate reservoir, and I don't think we've drained it yet, so we'll have to drain it. So I think what we're going to do is tear this one down first, and we'll take a look at some of the features of this, and then we'll tear down the aluminum one second, and you can see how different it really is. So these are an axial style pump. The shaft obviously runs down the center. It's got a swash plate, and the pistons go this way. That's what makes it an axial style pump, because it runs off of the same axis. So these are both held together with kind of a clamp system to clamp the body. So you got to take these off, and then you can start pulling the body apart. So we will do that. This is an old pump. This is off of my 75 step side project, and I know that it hasn't even been touched. I mean, it's kind of seized up, but it hasn't been touched for like 30 years, 32 years. So it's going to be kind of interesting to open this up anyway. I kind of wanted to do it, but I don't know what we're going to find inside of this because it's been sitting so long. This aluminum one is one of the ones that failed, and I've gone over this in some of the previous videos, and it was bad right out of the box. And I think somebody ruined it and then returned it, and then they gave it to me. But anyway, so we gotta spin these 4 bolts off here. Wow, as rusty as these are, I'm surprised the head is coming off this easy. All right. These are very durable compressor. It is a steel body, but they're built very well. They're made mainly by Frigidaire, but I believe there's a couple other companies that maybe made them under license. I could be completely wrong about that, but if they did, the design is pretty much precisely the same. Alright, so now we just need to pop this head off of here. Okay, so you can see almost all the A6s came with a screen behind the port. You can see there's even junk caught in there. Maybe that's just the folding of the screen, which is a nice feature because you can actually, you know, clean them. Now, if you look at this, this is your oil pump. You can see it's a gear rotor style. As this spins, it works oil between here and forces it out inside this casing, inside the body here, as this spins. And this is the back of the shaft. You can see these, goodness, that's quite the build up there around that pin. You can see these valves. These are like a reed style valve. This outer steel part limits the travel of the valve, and this inner part, you can see this inner reed part is what moves up and down. I'm not going to rebuild this thing because it's been sitting so long and I'm not sure it's worth rebuilding. That's why I'm playing around with it like this. But is this oil or is this is actually oil. Yeah. Old mineral oil. Okay, so this is what's called the head of the pump, and you can see that it has this extra oil pump feature, which very few AC compressors have. The seal's just disintegrated completely. And the fact that it has that pump means that it can survive on its own with the oil supply that's just in the pump, which is a pretty cool feature, actually. Let's see if we can pull this valve assembly out. Pretty bad. Okay. So this is called an A6 because the A is for axial and the 6 is for 6 cylinders. There's 3 on this end and there's 3 on the other end. And then they're connected down through the middle. All the chambers are connected down through the middle. So, well, there is a good amount of oil in there still. I'm kind of surprised. Old mineral oil. Okay. So, we have to continue taking the guts of this. This pump continues to slide out this way, out of the case. Alright. Little pickup. Get the compressor body out now. So let's take a look at this. As you can see in the case, it's all steel, very well made. The oil pump pickup comes through this tube here that you saw. It draws oil out of the sump, and then the oil returns through these holes and around the edges into the sump. Okay, so like I said before, this is a 6-cylinder, so the other 3 cylinders are on this end. Just remove this valve assembly here in my extremely gentle fashion. And you can see it's the same reed valve assemblies in and out as the other end of the pump. this is seized up good. The swash plate doesn't even want to move, even though it has some oil in there, but I think it just sat so long and all the oil ran out that it's just a mess. And like I said, I wouldn't have tried to rebuild this anyway, because it's just not worth the money. You'd probably have to have everything remachined, and so I figured it'd be better to use as a demonstration for you guys. As you can see, the cylinder bores are they're completely corroded, and I mean, everything needs rehoned and remachined, and it's not worth it. By that point, you might as well just buy a new pump. So, I mean, this is a good core at this point. That's about it. So you can see this has 6 huge displacement pistons. I say huge because when you see the other ones, you'll understand. So this works by a swash plate in the middle. As this rotates, the swash plate gets higher or lower and moves these pistons up and down. You know, standard swash plate pump. Let's take this apart so you can see how heavy duty this assembly really is. So this is really heavy. I mean, this is heavy steel. This whole compressor is very heavy. The aluminum one of its big selling points is it saves weight. And I get that. Weight savings are good, but there's some sacrifices you make for that. So there's a bearing in here. Just your standard. Goodness, that oil was old. Yeah, that bearing was pretty well walked up too. So you can see your swash plate. These little flakes are from the ceramic seal that I broke trying to get it out. Just ignore that. So these pistons, now these are aluminum white metal, but that's fine. So you can see that that there's a ball and a cup here, and the plate is what actually the cup part of the plate is what rides on this steel swash plate. Now you can see this is not this is brass, so it's made to wear a little bit, and although this is much more expensive, this is a much better way of doing it because you get much more longevity out of it as opposed to having like steel right on steel. This is much more gooder is what I'm saying. Now you see these actually they're stuck in the bores, but you can see that these have piston rings to seal just like an engine, and this gives you a real nice when these are new, this gives you a real nice compression and sealing capability that a lot of compressors don't have. A lot of compressors these days are just an aluminum bore and an aluminum piston, and well, just don't get the longevity out of it. This is one of the reasons why these things like just run forever, because of the, you know, just all the extra little features they have in here, like these brass cups and the piston rings and all of that. So even though these are aluminum, they don't actually ride on the steel bore. Just like an engine, they have a ring. Of course, there's bearings on both sides of the swash plate. These are really jammed in here, aren't they? Again, don't rebuild your compressor this way. So this has tubes that transfer refrigerant and oil throughout the compressor, more than just relying on the body of the compressor to seal it. Don't know if that's nicer or not. These are just locked in there. Okay. Yep. Again, your piston rings. Oh, this one's actually loose. So you can see, I mean, it's just like an engine piston ring. And here's your swash plate. As you can see, as it rotates, basically your piston moves forward or back. You know, as this rotates, your piston will move forward or back, because this swash plate doesn't. You know, it just rotates in place. Anyway, standard axial compressor operational theory. So there it is. So you can see there's a lot of little things in this pump that come together to make a really good AC compressor. And I think they made the pistons out of aluminum because they need to be lightweight. These pistons, since they don't ride on the cylinder walls or anything, that's fine. They can be lightweight. You know, just reduces reciprocating mass, helps the compressor run a little bit smoother, all that stuff. But the basics of the compressor are really good. It has really good, well thought out parts between these ball bearings and then the extra brass caps on them that ride on the swash plate. You can see, if you look closely, hope you can see it, the original machining marks on the swash plate. And this is a really old compressor, but you can still, you can see it there. I'll show you on both sides. Maybe you can see it in the light there. The original machining marks, and that's because all of the wear happens on these cups. And of course, once they're worn in, they have oil holes in the middle. And once they're worn in, they're going to ride nice and smooth and not wear too much more unless something gets into that compressor or something happens. And of course, they are riding on another ball bearing inside the piston itself. These are really well built. Even the swash plate is very thick and heavy, and standard bearings, but these are good bearings, even though they are just seized up like a rock from sitting. This compressor would take a lot of money to rebuild, because you'd have to replace a ton of these parts, and like I said, you probably have to re-hone these cylinders. And the kits they sell, you can't get things like, I don't think you can get the rings or anything like that. Mostly they're just a seal kit, but you know, you can probably special order that stuff if you really wanted to. But in the end, it's going to be cheaper to buy a already rebuilt one and send this back as a core. Anyway, so you can see how good this is. So let's move on to the aluminum compressor for comparison, and we can take a look at that one. So this comes apart like the other one. The bolts just come out of the head instead of the rest. Now obviously this has already been disassembled because I did a evaluation on it to see what went wrong. But it just separates into parts here. You can see the valve assembly is similar. Reed valves, these valve plates just come right off of here, and it's very simple, cheap to make. It has kind of this metal thing that's supposed to act as a stop, I guess. This is your stop plate and the head of the compressor. Again, all aluminum. Obviously the reed valves are special grade of steel. So you can see this is a 10-cylinder compressor because it has 5 really small cylinders. I don't know what the displacement is. Somebody who's really good at math could probably calculate this, and I mean, I could calculate it if I wanted to take the time to do it, but I don't know. It could be roughly the same displacement. I don't know, but anyway, this ends up being a 10-cylinder, so it's really like an A10 compressor instead of an A6. But again, all aluminum. Let's take this apart. So here's the cylinder unit. Again, all aluminum except for the needle bearings in the middle, obviously. And then you have your pistons. They have a groove here, but they don't have any rings or seals or anything. They do have bearings. Notice how they're much larger and, you know, kind of lower quality, really. You know, but same swash plate concept. But the difference is, let's see if I can get this. kind of a smaller swash plate, and it is steel. The steel shaft and swash plate. No oiling holes in the shaft for bearings or anything. And you can see these are, again, aluminum pistons, much smaller. They don't have that brass surface. Your swash plate is riding right on here. And that's one of the failures that went bad here on this pump. As you can see, it started digging into that, probably because either someone ran it without oil, or I don't know, they ran some grit through the pump or something, or there was resistance and it reached that point and it was fighting something at the top and ground into the swash plate. So you can see, and this one failed, you know, pretty new. There's no oil sump. There's no oil sump, there's no oil pump. This bolt, this kind of fake oil sump bolt, just goes right into the main case, and all of the oil and refrigerant and everything just circulates in the case like a normal compressor, not like the A6 with a separate sump on it. So, and of course all these pieces are aluminum, which makes it much more lightweight, but also makes it less durable. And the seal is different. I kind of like the front seal. They did improve the front seal on these. It's more like a Sandon style front seal on these. It's not only easy to replace, but seals a little better. You can get improved seals for the A6. They're just harder to replace because of recessed snap rings and all the other stuff that goes on there. But you can kind of see, you know, you can see the original machining marks on here and how new this thing was, and it just failed right away. And if that's something, if you had oil in the system but not in the sump when you started it up, and you didn't rotate it a few times to get that oil circulated after sitting, you know, you could do that. But the A6 pump, as soon as it starts to circulate, that oil pump starts to turn and pull oil out of the sump and run it, you know, through the compressor, through the shaft, and into the bearings and all the other stuff to lubricate it. Much more durable compressor. And you can see this thing has a lot of case O-rings between the sections. All these sections have O-rings, which is more leak points. The other case is a lot less, the case itself is less prone to leaking because it just has the head unit, the seal at the head, and the seal at the front. Now, of course, like I said, the front seals are a big failure point in the A6, but you can get improved ones. So it is aluminum, and of course, you know, if you overheat this thing, it's going to be a lot less forgiving because there's more seals to fail, and it's aluminum, so it's going to warp sooner than the big heavy-duty steel of the original A6. So this should really be called an aluminum A10 compressor, but they're calling it an A6 because they're saying it's a direct replacement for the A6 compressor, which bolt-on wise and functionality wise, it pretty much is a direct replacement. I'm running one of these right now in my El Camino, and performance wise it does as good a job as the A6 does. I'm kind of impressed, but I don't know how long it's going to last. That's the difference. It is lightweight if you're worried about that kind of thing, but, and by lightweight I mean it probably saves like 40 pounds. That's there's a lot of steel in this old A6 compressor. Yeah, and this compressor really isn't worth rebuilding either. I kind of went over that in a previous video because, you know, everything, there's probably grit been run through it, and cylinders are scored. You probably can't see that, but they are. Because there's no rings on this. It's just this aluminum riding directly on that aluminum. And you can see you need a really tight seal in there. And one little leak and one little groove and you're gonna start to lose compression. At least with a piston ring it might tend to, you know, be more forgiving on that, like they are. The bearings on these about the same, needle bearings. Again, the needles themselves are a lot larger than the smaller, more, I don't know, there's more needles in the other ones is what I'm saying, and there's less needles in here and more empty space. I think I kind of prefer the more needles because it's a smoother, just better all around bearing. The bearings on these are, well, they kind of cheaped out. Just like the A6, it does have the expansion release that'll pop off valve if it overpressurizes. And it does have the option in the head unit to put in the either the superheat switch or a high pressure switch, high pressure cutoff. The superheat switch is temperature respondent, and if it gets too hot, it'll open the switch or close it or blow a fuse kind of inside of it. Some of the older ones use that as a safety feature. If it got too hot, pushing too much gas, it would blow that and or open it and shut the compressor off. Rather than using a pressure dependent, they went off the superheat. The bearings strike me as pretty cheap all around. Have to be well lubricated, but you definitely, since this doesn't have an oil sump, not really, any oil you put in is going to be distributed throughout the entire system. It's not going to stay in that sump. I mean, a little bit will, but it doesn't have a pump to draw it in, and it doesn't have a circulation system inside the compressor. So 100% you cannot run this as an air compressor without oiled refrigerant in it, in the system, like you could, sometimes people do with those A6s. And again, you're going to have some oil leakage, you know, out of the compressor, so you got to top your oil off if you're going to do that. But just like any compressor, you should be checking your oil anyway, because you're going to have possible oil leakage into the airflow. So yeah, I don't know what else to say about this other than this is a workable compressor by today's standards, but by today's standards, of course, cheaper than yesterday's standards where everything was built heavy duty and to last and over engineered. The A6 is the original steel A6 is way over engineered, which is good because the conditions under which a compressor operates are sometimes pretty bad, pretty harsh conditions when people abuse them, and it's really hot under the hood, things like that. So these are cheaper because, you know, they're all brand new, they're not remanufactured, and they're just coming off an assembly line. They don't have to have somebody remanufacturing these parts and disassembling them and putting them back together again, checking clearances, that kind of thing. They're just coming off an assembly line, they're checking clearances, and they're popping them together and into a box. So you'll save a couple $100 on average with one of these new aluminum ones over the A6. Is it worth it? Well, I'm not sure. I guess it depends what you're looking for. Like I said, I don't know. I have one in this El Camino here, and it's been in there, what, about a year now? And half a year, I think. And, you know, I don't know. We'll see how long it lasts, but I know that these old A6s will last for practically a generation if you take care of them. And you can modify and drain and refill the A6 with a newer oil to run R134A. So, you know, they can easily come into today's world fairly simply. But, you know, in the end, they're built stronger and they don't have 100 case seals. These are a throwaway compressor, basically, is what I'm saying. The A6 is a rebuildable compressor. This is a throwaway compressor. When you're done with it, you send it back and, you know, they melt it down and make a new compressor out of it, basically. So that's our evaluation of the two compressors, the A6 and the unit they want to sell you as a replacement for the A6 these days. And hopefully now that you know the differences of them, you can make an informed decision. So the original A6, a rebuilt, remanufactured, is going to cost you probably a couple $100 more. These are probably about $600, $700, $800 for a good one, and I would probably spend the money for a good one if you're going to buy an A6. I've got some cheap ones, and they cheap out on the seals and everything, and then it's not worth it. Even if the internals of the compressor are good, if they've cheaped out on the seals, you've wasted your money. So spend the extra money for a good quality, reputable, rebuilt A6 if you're going to buy one. The aluminum ones, I think Four Seasons, there's a couple manufacturers who make them. I don't know if they make them under license from someone else, or but because it's a bespoke design. There's nothing the same design-wise between these two compressors. I think Four Seasons makes them and a couple other companies, but they're much cheaper. $300-400 can get you one of these easy. Probably cheaper than that if you shop around. And, you know, it'll probably get you a couple years, just like a modern aluminum compressor. And if you take care of it and you make sure you monitor the oil in the system instead of just pumping in refrigerant if it's leaking somewhere else, and, you know, pull the charge in the oil and replace with proper charge and proper oil charge and keep that oil in there, you're probably going to have a good chance of keeping a good life on one of these compressors if you take care of it. But if something catastrophic happens, this compressor is going to be instantly shot. If you get garbage or something inside that compressor, it's going to mess the whole thing up. One of these you could rebuild or clean it probably, but you know, one of these, no. It's a throwaway compressor, I think, like I said before. Basically, you know, this is a throwaway. The originals are rebuildable. So hopefully that's enough information to make a good informed decision. I do these videos to kind of help people out, hopefully. So hopefully this helps someone out. If you liked it, we do a lot of stuff like this on the channel, so feel free to like and subscribe so you see more of what we do, and feel free to leave a comment down below. And as always, thanks for watching.